We're now going to discuss molar conversions, which require two steps. In order to perform problems that require going from grams to atoms, you first need to set up a conversion box and solve for moles first. Once you have solved for moles, you set up a conversion box and solve for atoms, molecules, using Avogadro's number. When going the other way, going from atoms or molecules to grams, we set up the conversion box and solve for moles first using Avogadro's number. And once you have solved for moles, then you set up a second conversion box and solve for grams using the molar mass. The info that you need in order to solve these problems are the molar mass and Avogadro's number. This roadmap basically, again, is used as starting and ending points, except we are now going to go in two directions. Okay? Two directions meaning we can go both ways. But we have to remember that we need to stop off at moles in order to convert between these two units. Here are some example problems. How many grams does 1.12 E22 molecules of iron 2 oxide represent? Well, the first thing I need to remember is this E stands for times 10 to the 22nd power. Okay? So it's really saying that it's 1.12 times 10 to the 22nd molecules. Okay? So I'm going from molecules to grams. Two steps. First step is I put down my given information. Second, I figure out a conversion box. And the conversion box that I want is I want molecules on the bottom, moles on the top. The reason why I want molecules on the bottom is to get rid of it. Second step is to solve for grams. So I have to do one more step in figuring out the correct formula of iron 2 oxide, which is F2 plus O2 minus, which gives me FeO. So the molar mass of FeO, or iron 2 oxide, is 71.84 grams. And again, moles cancel out. Multiply the top, divide by the bottom, and I should get 1.34 grams of iron 2 oxide is represented by 1.12 times 10 to the 22nd molecules. Next type of problem. How many molecules does 15.8 grams of silicon dioxide represent? So I'm starting with grams and I'm going all the way down to molecules. First step, figure out this thing right here. What's the formula? Well, silicon dioxide is SiO2. Alright, next step is I need to figure out the molar mass of SiO2. So, I start off with my given information. I figure out the molar mass, which is 60.08 grams. And again, I'm making sure that I have my units that cancel. Grams on top will cancel grams on the bottom. But I'm not done yet because I need to go all the way to molecules. I've only converted to moles. So I need to take one more step where I apply Avogadro's number And moles cancel out, so that's what I want on the bottom, and I multiply it by 6.02 times 10 to the 23rd. When I do that, I get my answer as this. Last thing that I want to be aware of is my use of significant figures. Since this has 3 significant figures, my answer needs to be in 3 significant figures. Since this right here, the starting point is 3 significant figures, then my answer is also in 3 significant figures.